Yes, just about the virtual machine, we can start. So yes, this workshop will be about mobile hacking, the Android mobile application mostly. And so in fact, we are going to resolve the OWASP Android crackmes level 1, 2, and 3. And for that, we are going to use some common tools used for accessing Android mobile application. So for this workshop, I provided a Kali Linux machine with all needed tools already set up on this virtual machine. So if you are able to download the virtual machine, so to authenticate, you just need to put Kali. Yes, so don't forget the keyboard is using the US layout. Okay, so just be aware of that. So the username is Kali and the password is roundresec. Okay, and then we can start the virtual machine. Great. So let me see. So okay. So on the Android directory, you have the OWASP crackmes inside. Okay, and so I already performed a git clone of the Github repository. So I'm going to show you the slides. So the slides are also on the GitHub. So for the slides, I recommend you to use Firefox to read them. Okay, perfect. So we are doing like that. Okay, so that's the slides. So as I said, the objective is to perform some basic testing on Android application with common tools like ADB, Apk Tool, JADX, Frida, and so on. Where can I write? Yes, the password is roundresec. Is the name of the company. You can see it here at the end of the slide. And don't forget, it's a US keyboard layout. So just be aware of that. Okay. So yes, I said about the Android crackmes, OWASP crackmes. So normally you should have this link to download the virtual machine. I hope you already done that before this workshop. First thing to do is to clone this GitHub repository. On this repository, you are going to have the Android and iOS workshop. So just use the Android directory for this workshop. And you have also the solutions and the slides. Okay. Yes, the slides are available on the GitHub repository. Okay, so if I show you, I already performed a git clone, and so you can see on the apk directory workshop. Okay, on my case, I have only Android, but on the Android directory, you have the slide. Okay. Okay. No more question for the people having the virtual machine. Everything it's okay. So for the setup of this workshop, so you have the Kali Linux. On this virtual machine, you have Android Studio installed with already 2 emulators set up, Anuga and Lollipop. We are going to see that later. If you want, you can use your own rooted device to perform the workshop. You just need to connect it to the virtual machine through USB. We are going to use Apk Tool, JADX, Frida, Ghidra, and Objection. So yes, again, the credentials, Kali, randorisec for the password, okay. And don't forget the US keyboard layout. For the emulator, so you can launch them using Android Studio. So if you want, you can go there and launch Android Studio, okay. But just to launch the emulator, you can also, there is an alias with Nougat. And if you do that, the Android emulator is going to launch, okay. Okay, normally if no errors, because running an emulator inside a virtual machine, sometimes you get some weird errors, but normally for this workshop, it should work really great. Okay, so you see, we have the Nougat emulator running inside our virtual machine, okay? So I encourage you to launch the emulator right now, just to speed up the workshop. So yes, with Android Studio, mostly we use Android Studio for creating Android application, of course, but also for debugging, for the logcat functionality, if you want to see the logs of your mobile application and the system, and also to manage emulators. So on the slide, I give you some, I give you a walkthrough, in fact, on how to create an emulator. So it's pretty simple. Maybe I'm not going to lose too much time on this, but if you want to create your own emulator, you just need to follow the following steps. Create, select the hardware you want, for instance, here an Asus 5X. Then you need to select an image. So if you want Nougat, Lollipop, Marshmallow, and so on. So be aware, if you want to have root access on the device, you need to select the images with Google APIs here. Okay. If you select another one, you are going to have a kind of a production release. And so, in fact, it's like a real device you bought. And so you need to root it like a physical device. So if you want to avoid this, just select the images with Google API, okay? And in that case, you don't need to root anything. The image is already rooted for you. Okay, I already sorted all that. In the case of running the emulator on a virtual machine, okay, it's important to select the software graphics performance to avoid some issues. Oh yes, and I forget, don't select ARM images, but x86 or x86 64 bytes images, okay? Because if you try to run an ARM image on a x86 architecture, it's going to take too much time, and so yeah, it's pretty really annoying. Okay, and so after that, after all the steps, you have your emulator ready, and you can run it using Android Studio. Okay. So again, we are also going to use ADB. So it's just a command line tool to interact with your Android device. Okay. Maybe I can show you real time. So in this case, let's open a new terminal. Okay. So IDB devices, for instance, to list the devices running on the device. In this case, we have only this emulator. Okay. You see running. We can perform ADB shell to obtain a shell on the machine. Okay, in this case you see okay, yes, we are root, so that's good, and then we can perform commands inside the emulator. Then we are going to install some Android APKs. For instance, we can already install, I'm not on the good repo. We can already install the uncrackable level 1 of the Android crackme. Okay, and that's it. And then we can switch to the emulator and see it's correctly installed on the emulator. Good. Okay, so some few Okay, so okay, yes. So for people don't having root when running IDB shell, you can relaunch ADB with root. Okay, in my case, I'm already running as root, but if it's not your case, just type ADB root, and after that, you should have a root access on the emulator. So someone wants the git clone. This is a command if you want to retrieve. Okay. Just change someone else. Okay, so just some examples of how you can use ADB. Okay. Then another interesting tool, Apk Tool, mostly for decoding APKs or building new APKs. So in fact, when you are going to use Apk Tool, when you decode an APK, you are going to obtain some files like the Android manifest decoded, and also some representation of the bytecode, the Dalvik bytecode of the APK, which is called Smally. Okay, and Smally is how to say, a human readable interpretation of the bytecode you can edit and read. Okay, so to use Apk Tool is pretty simple. So let's take an example. You want to modify an APK, an Android application. So first you decode the application with Apk Tool with a D option, okay, with your APK, and then you can specify an output, a directory output. Then you perform some modification. For instance, you modify the Android manifest, or you modify some Smally code inside your application. So just to give you an overview of Smally code. So here we have a small example of a class. So you can see some keywords here with specifying that the name of the class, which is here SG vantage point AB. Okay. We see that the parent of this class is object, which is normal for Java. And then we have a method specified here called A, okay, with a parameter here, which is type context. Okay, and then we have some code. Okay, at first it's not really easy to read this kind of code, but after some practice, you are able to identify what the application is doing. Here we are calling a function get application context, and here we have just if condition. Okay, but it's pretty a mock example just to show you some Smally code. We are going to see later on a real example. So after your modification, you can rebuild your Android APK. So with the B option for build, you take the directory where you perform the modification, and then you specify, for instance, a new name for your APK. After that, if you want to use this application on a real device, you need to sign it with using, for instance, jar signer. Okay. In this example, so you see the command line is pretty long, but in this example, we are using the debug key store. Okay. And after signing the application, normally you are ready to go. Sometimes you can see some documentation saying that you need to perform zip align. From my experience, it's not mandatory. I mean, if you don't perform this step, the application is going to work anyway on the device. From the documentation, normally zip align is used to provide some optimization on the APK. So okay. So if you want, you can perform it. I'll let you the command line if you want to use it. But in this workshop, we are just using jar signer to sign the Android application, and that's it. So here an example to create your own key store. So if you don't want to use the Android debug key store, provided on the Android SDK. Okay. Okay. Someone is saying that we can't upload APK to Play Store without zip-align. Okay. I was not aware about that. But I mean, on our case, if you just want to test on your device, okay, it's not mandatory to do it. Yes, so if you don't want to use the Android debug keystore provided by the Android SDK, you can create your own. So on this example, we have a one-liner example. So just with this command, we are going to create a keystore called my Android keystore with an alias key called my keystore. And the password for the keystore will be keystore pass, and so on, and so other options. Okay. For this workshop, we are going to create this keystore. So I encourage you to copy paste this command line. Okay, and to create the keystore, for instance, we are going to create it on the OWASP crackmes. It will be easier for later path keyboard. Okay, sorry, already created. So yes, the keystore is already there. Apk keystore. Okay, so we are going to use this keystore for the next exercises. Okay, and we are going to use this command line to sign the Android applications we are going to modify. Okay, we are going also use a lot JADX to obtain a Java representation of the Android applications. So you have an example here with the uncrackable level 1. Okay, more on that later. We are going to use Ghidra also, mostly for reverse engineer some native libraries we can find on Android application. So we are going to see that on the uncrackable level 2 exercise. And that's all for the most common tools we are going to use. So I propose to start with uncrackable level 1 exercise. Okay. So this crackme is pretty simple. There is a secret inside the Android application. We need to find it. In this crackme, the sensitive part of the code is obfuscated. We have some obfuscation performed with ProgWard, but nothing too much heavy in terms of obfuscation. So for this workshop, I propose to resolve this crackme using different ways. First, we are just going to temper the application. Okay, so no Frida or dynamic analysis. Mostly just take the Android application, perform some modification using Apk Tool mostly, and to retrieve the secret. Okay. Then second option, we are going to use Frida. Okay, we are going to use it to resolve it, and we are going to assume that we are going to use a rooted device. Okay, in our case, the emulator is rooted, so that's okay for us. And the last step, we are going using Frida again, but this time let's assume the emulator is not rooted. So in this case, we can still use Frida, but we need to use the libgadget library provided by Frida and to inject it on our Android application. So yeah, the plan for this crackme is to use this to resolve it using these 3 ways. Okay. So first, let's have a look at the application and see what it does. So first, let's use JADX, okay, and take the uncrackable level 1.apk. I hope, yeah, I guess you are going to see well. Perfect. So the first thing first, when you are looking on the Android application, most basically, we can start looking at the resource files and the most obvious one is the Android manifest.xml. Okay, so in this case, the application is pretty simple. So the Android manifest is small. Okay, in fact, you can see we have only one activity. Okay, so one activity, we can simplify things if each activity is a screen of the application. Okay, so in this case, we have only one screen, and so we have only one activity defined on the Android manifest. So obviously, because we have only one activity, is a main activity, is the main one. But we can confirm that because of the intent filter here. Okay, and with the Android intent action main. Okay. So let's start by looking at the main activity here. So we can click on control and then click left, and we go to the main activity. Okay. On an activity, on an Android activity, you have some default methods present. So the most obvious one is the onCreate method. So this method is executed when you launch the Android activity. Okay. So in that case, if we look at the onCreate method, we see that first 3 calls of these three different methods are performed, and then we have a function called with a string parameter root detected, and then we have another function b.a. And again, if this is true, we have the a function called with the string app is debuggable. Okay, so from that we can guess what's going on here. And so the first if is testing if the device is rooted, and second if is testing if the application is debugged. I mean, if a debugger is attached. But we can confirm that looking at the content of these three methods. And so we can see, so c.a, so the A, B, C methods are on the SG vantage point AC package. So let's go there and see what happens.
Guillaume, sorry to interrupt you. I just want to update everyone that if you want to follow the slides, you can find them in the GitHub repo, in the link that we shared before.
Yeah, sure. Yeah, the slides, yes, I say that on the beginning, maybe it didn't turn, but yes, the slides are on the GitHub repo, of course.
Thank you.
And so on the C class, we are going to find the A, B, C methods. Okay. So the first method A is just looking if we have the SU binary on the path. Okay. The B method is just looking at the build tags of the Android system and test if there is a test keys on the string. And the last method is looking for some common binaries or files, we can say, files available on the system. And these files are usually used when you root your Android device. No. Right, just a minute. Get the slide. Sorry, just answering someone. Okay. And so what happened for each method? If they found these files or these test keys or the SU binary on the path, they return true. And if we are true, so the application detects that the device is rooted. Okay. In fact, we can test it right now on the emulator. If I launch the Unbreakable level 1, you see we have kind of a pop-up saying that root is detected. Okay. So makes sense because it's the same string on the code, inside the code. And so this is unacceptable, sorry. The app is not going to exit. And if I click OK, the app is exiting. Okay. So that's for the root detection. And so we can look at BA. So it should be there. And yeah, it's just looking for a flag to see if the app is debuggable. Okay. But in our case, we don't care because we just need to run the application on our rooted device. Okay, and we are not going to debug it. So let's go back to the main activity. And so after that, we can have a look at the A method, okay, which is called when root is detected or when the debug option is enabled. So this function is just up there. Okay, you can see with the string parameter. And we have an alert dialog created, okay, with the message, this is unacceptable. So what we see earlier, okay, and we just with one button, okay. And when we click on this button, system.exit is called, okay. Okay, so that's for the first part. So if we want to go further on this aspect, we need then first to bypass this root detection. Okay, so maybe you have already some ideas to do that. But let's look at the rest. So after that, if we bypass the root, we need to find the secret. And we see on the main activity a verify function, which is called, so maybe I can show you again on the emulator. But you see there, you have to enter a secret string here and click on the verify button to check if you have the correct secret, okay? So when you click on the button, in fact, this function is called, okay? In fact, you can verify that looking at the resources, not here, here. If you go to, no, sorry, that was good. On the layout of the activity main, you should find, yes, you should define the button, verify button. Oops, sorry. And you see a parameter Android on click verify, and verify is the name of the function called when you click on the verify button. Okay. So let's have a look at the verify function. Here we retrieve, this line is just to retrieve the user input, okay? So it's stored on the obj variable, okay? And then we have the AA function called with our user input. If this function returns true, we have success, this is the correct success, secret, or you have nope, that's not it, try again. Sorry, someone, yeah, someone raise your hand. Yeah. Can you talk now? Okay. Okay, so let's continue. So let's have a look at the AA function. So this function is present here. No, it's on. Oh, sorry, it's an uncrackable one. Yeah, because it's on the same class, on the same package. Sorry, of the main activity. So if we have a look there, so we see our function A. Okay, taking our user input here and returning a boolean. Okay, and in fact this function is calling another one function, SG vantage point AAA, and it took two parameters, this one and base 64 data also. Okay. So maybe you have already an idea what's going on there. Thank you. And then this, the result of this function, which seems to be a byte array from the name, yes, from there, is compared to our user input. Okay. And so if it's equals, we are going to have true. If not, we are going to have false. Okay. So now we can have a look at this function, which is R there. And here we can see something pretty common, which is a iOS decryption routine. Okay. So the first parameter here is a key. Okay. And the second parameter is our secret encrypted. Okay. Which makes sense because this B64 is a secret encrypted with iOS, and this is a secret. Okay. So this is decrypted and then compared to our user input. If it's equal, we found the secret. So basically, to find the secret, it's pretty simple. We just need to retrieve the result of this function and to display it to have the secret. Okay. So let's do that by tempering the application. So you have the same thing on the explain on the slide. Okay, what I told to you right now. So yes, to bypass the root detection. Oh yeah, yes. In fact, we don't talk about that. To bypass the root detection, I don't know if you have some ideas, but yeah, we have many ways to do that. So let's back to the main activity. Sorry. So, in fact, you have two obvious ways to do that. First, we can say, okay, we are going to modify the ABC functions to return false each time. So that's a way to do that. Another way is, in fact, you can observe that if you click on the OK button, the system.exit is called. So in fact, we can modify here and remove just the system.exit. So we are going to have the pop-up, but even if you click on the OK button, nothing is going to happen. Okay. So for tampering, so let's do that. It will be easier. And for the secret, as I told you, let me close that. In fact, we can modify here this function just to return, to display, in fact, the content of this variable, which contains the secret decrypted. Okay. So we can, okay, I already told that. So in fact, on the slides, we can follow the slides to resolve this. So using Apk Tool, let's decompile the applications. I'm going to open a new terminal. Okay, let's decompile it. Okay.
So we have a question from the audience.
Oh yes, if we set cancelable to true, that will also work as a bypass to avoid app from exiting, right? Yes. Exactly, yeah. It will work. It will work if we do that without any issue. Yes. In fact, there are many ways. I presented just the two obvious ones, but yes, you can find other ways to do that. So after that, normally we have a directory called uncrackable level 1. Yeah. And you see, we can retrieve the Android manifest, for instance. Okay. And so the idea is to modify, first, we are going to remove the exit call. Okay. So we can, if you want, you can search it with a grep, for instance, on the repo, on the directory. Okay, strange. So for instance, exit. Okay, and so you can identify the smiley file where we have the call of the system exit. Okay, and so we are going to remove it. Okay, on the example I use nano, but if you prefer Vim or whatever, it's up to you. Okay, and now, yes, so you see here the invoke static and calling the system exit method. So we just need to remove these two lines. Save the file, exit. So for now we have bypass the root detection with this, just this small modification. And now, oh, okay, no issue with the PDF. But now we are going to display the secret. So to display the secret, yes, I can show again. So yeah, in fact, I already moved it, but on the onClick method, you see, on the main activity $1.smiley file, on the onClick, normally you have these two lines, and we are going to remove them. And removing those two lines, in fact, we are not going to exit anyway after that. Okay, so I just removed two lines. Then to display the secret, what we can do is we are going to modify this file a.smiley, where we have the, if you remember the JADX, yes, on this file, we have the call of this method, and the result of this method gave us the secret decrypted. Okay. So the idea, we are going to just display the content of this variable. For that, to have something simple, we are going to use logcat, the logcat feature of Android. So we are going to add two lines to display on the logcat the secret decrypted. Okay. So I'm going to show you. So if we edit this file, so here you can see the A method. Okay, so it reaches the same of this one. You can see some strings already so on the Java code. Okay, we have here. We have the decode function called. Okay, and if you continue. So the sg.vantagePoint AAA function is called. Okay, we have a try catch here, and if we don't have an exception when calling this function, we are going to the go to 0 label. Okay, and if we go there, it's just a catch, but we don't care about that. Yes, so go to up, and here we are going to perform the str equals compare with the decrypted value. Okay, here we are going to compare it. So we just need to add some lines after this one. Okay, because there is just a conversion, kind of a cast of the byte array on string. Okay, so to display it, it will be better. And then this call is just to perform the equals comparison. Okay. And so for, if you look at the slide, for the logcat, we not just to define a tag, okay, to display our message. So we are just going to add a string called result to grep it more easily. Okay. And then the next line, okay, I'm not going to see it very well, but it's just a call. It's just a call to display the result. So v2 is just a local register we are going to use to store the result string, okay? And if you look at the result of the init function, just to create, to cast the byte array on string, is stored on v1 register, okay? And so we are just calling log.d method with two strings. The first one is v2, is a result tag we are going to use to catch our result on the logcat, and v1 is a decrypted secret. Okay. Yes, I had something. Yeah. So we just need to add those two lines to reveal the secret. So we can write it. Okay, question. And that's it. After that, we just need to, you can see the results are here on the screen, okay? Just after the new, in fact, this is the same as a new string you have on the Java JADX Java code here. You see, new string of the byte array, okay? It's just to cast it on string type, okay? And we are displaying it on the logcat. So now pretty simple. We just need to rebuild the application. Okay. So just giving the directory. I'm calling it new ul1.apk. Okay. Okay. No error. So it seems good. So now the jar signer command to sign the APK with a previously created key store, ipsec.keystore. Okay, we see everything goes well. It's correctly self-signed with our key store. Now we just need to uninstall the application from the emulator, because we can't install two applications with the same package name. Okay. And now we can install new ul1.apk. Okay. Success. Now I can go to the emulator. I can launch the new uncrackable level 1 I created. So I have still the pop-up, but it's normal. Okay. We didn't remove it. And now if I click OK, the application doesn't exist. Okay. Makes sense? We have removed the system.exit code. Now I can type whatever I want here. Okay. Sorry, Android say, oh, let's make OWASP. Click verify. Okay, and not a secret. But I forget to look at the logcat and perform a grep result, which is a tag we use on the code to display the decrypted secret. Now, if I do that, we see that we have on the logcat the secret decrypted, which is I want to believe. Okay, so now to show you with the correct secret. I want to believe. Okay, I'm going to click on verify. You see we have another logcat display, which is normal because now we have modified the application. So each time I'm going to click on verify and the function, the decryption method is called, we are going to have this secret decrypted display. And now we see we resolved the crackme and we found the correct secret. So let me see. Okay. So yes, for that, you can you have various ways to do that. For instance, let me find. Let me can do that. On the previous commands, for instance, we can list the package installed, the Android applications installed on our emulator. Okay. And we can find the name of the package of the OWASP one, which is owasp.mstg.uncrackable1. Okay. So this is one way to do that. Okay. We can also list the application running with IDB shell PS, and you can confirm here we have still OWASP.mstg.uncrackable1 running right now on the emulator. Okay. And of course, with the code, you can see when you look at the source code on the main, not here, sorry, on the Android manifest, you have the package name also on the Android manifest, which is, where are you? Okay, it's not here in the values. Oh no, sorry, package. And you have the package name, OWASP MSTG uncrackable1. Okay, so you have various ways to find this value. Okay, so that's it to resolve it using just tampering. Sorry for the PDF. I guess the conversion had some issues. I'm going to put a new version after the workshop without these issues. And yes, okay, just an example here with a result. Okay, so we did it for code tampering. We are going to use Frida. Okay, maybe just let me remove it and install the original one. Okay, so that's good. Okay, with no question, let's keep going because we have a lot of to do. So just a quick recap with Frida. So if you don't know, Frida is a toolkit allowing you to perform dynamic code instrumentation on your Android application. In fact, you can use Frida on various kind of binaries, for instance, on Windows, macOS, Linux, iOS, and so on. Okay, which is powerful with Frida. You can use it on a rooted device. Okay, so we are going to see that after. So you just need to put a Frida server binary on your emulator or on your device, on your Android device. Or you can use it also on a non-rooted device, which is cool. So you just need to use it on a non-rooted device to repackage your Android application with the Frida gadget library, which we are going to see after also. Okay, so yes, here I'm explaining how to install Frida. It's pretty easy with pip. Okay, we can perform pip install Frida tools. Frida if you want the Python bindings. Okay. If you want to check the architecture of your device or emulator, just remember this command. Okay. On our case, the emulator is x86-64. Okay. In the case of a rooted device, you need to download the Frida server from the GitHub. Okay. On the virtual machine, you already have it on the Kali Linux machine, and then we need just to push it and to give execution permissions on the file and run it. Okay. So if you look at your machine, in fact, on the home Kali directory, you have a Frida directory, and you have Frida server and Frida gadget. Okay. So if you want, you can just perform these commands to push it. No, I guess I already have it on my emulator. Yeah, I have it running. And so when you have already executed on the emulator, you can use some Frida commands. For instance, okay, the most common one is Frida ps. Sorry, Frida ps -u. So this one is just for listing the running application on your emulator. Okay. So to test if your Frida server is correctly running, you can perform a Frida ps -u. Okay. So remember, to run the Frida server binary, you need to have root privileges with IDB. Okay. So if you have kind of error saying SU Linux permission and so on, it means you are not root. So perform ADB root to grant root privileges with ADB. Okay. If you have that, it's okay. You can run Frida without any issues, like we have here. Okay. Okay. Here's some examples. By default, so I show you Frida PS just to list the Android applications running on your device. Usually, you are going to use a Frida binary to attach to an existing process or to launch a process. So by default, if you launch Frida, yes, I didn't say the -u is to connect to a device connected through USB or an emulator, for instance. I mean, you are going to tell to Frida to connect through USB or to an emulator with this option. Okay. If you don't give this option, you need to specify an IP address, for instance, and a port. Is if, for instance, your device is connected through Wi-Fi. Okay. So by default, Frida tries to attach to an existing running process. If you want, you can spawn an application. You just need to add the -f option, okay, and specify always the package name of the application you are going to target. So by default, if you use the -f, Frida launch the application and kind of put a breakpoint at the beginning, and then you need to type %resume to continue the execution. If you want to avoid that, you just need to add the no pause option. But we are going to see that with some examples. Okay, so to enjoy the power of Frida, you need to create some what they call Frida scripts. Okay, so the Frida scripting engine use JavaScript. So if you want to create your own Frida scripts, you need to do it in JavaScript. Sorry, even with the Python bindings, at some point you need to write JavaScript. So yeah, I'm just introducing some basic Frida functions available on the API. So this function is to interact with Java code. Okay. So the one you are going to use every time is java.perform. Okay. And this function you are going to insert your hooks here. Okay. We are going to see with an example. It will be simpler to understand. So Java perform, okay, you are going to use it every time you need it to hook Java code. Then one other important is java.use method function. It's needed to use a specific Java class inside your Android application. Okay, for instance, we are going to see, but for the uncrackable level 1, if I want to hook this function, I'm going to say before I want to use this class, and on this class I'm going to hook this method. Okay, I'm going to show you. But yes, java.use, and then two other important keywords in this case: implementation and overload. Implementation is just to specify, okay, we are going to modify the implementation of this specific method. Okay, and overload is just sometimes on Java you have the same function with different prototypes of, I mean, the parameters, for instance, are different. And so with the overload keyword, we can specify the specific version we want to modify the implementation. Okay, because if you don't specify and Frida found that for this function you have, for instance, 2 prototypes, and it's not able to determine which one you want to modify, you are going to have an error. Okay, so just a very simple example. Here we are going to modify the Java code of the Unresume function. Okay. So an Unresume function is like the onCreate for the activity, Android activity. Okay. So what we are going to do to hook this method. So first java.perform, as I said, function, and then your code here. So we need to modify this function. We need to use the activity class. So for that, I create a variable called activity. Okay. And I use the java.use method to specify the class I want to use. In this case, for the activity, Android activity is android.app.activity. Okay, so I put that. And then, so I have this kind of weird syntax. I use this class, activity, android.app.activity, and I specify I want to use the Unresume method. And with the keyword implementation, I specify I want to modify the code of this method. And then I use the equal sign and I redefine a new function for the Unresume method. Okay, in this case, I'm doing nothing. I'm just displaying on the Frida console a message, displaying a message saying that the Unresume method was called. And here I'm just calling the original Unresume method. So you see that because of the this keyword used here. Okay, so pretty simple. So I put this, for instance, on a file called myscript.js, and then I can launch it. I mean, you can launch this Frida script. No? It's going to work on the Chrome, Android Chrome application, and with this command. Okay. And each time the Unresume function method is called, you are going to see a message displayed on your Frida console. Okay. So okay. Now let's imagine how we are going to use that to bypass the root detection on the uncrackable level 1. So for that, remember on the cut tampering, we modified the code in order to remove the system.exit call. So in this case, we can do the same with Frida. We are not going to remove the exit call, but we can say, okay, each time the system.exit method is called, we do nothing. Okay, so something pretty simple. So in Frida, it's pretty easy to do. So again, so you have it on the GitHub repo, on the uncrackable level 1 directory, this script. What we do, java.perform, okay, it's mandatory. Just a small message to say that uncrackable level 1 is starting. Yes, sorry. Okay, here we are going to use the Java class java.lang.system. Okay, I put that on the variable called sysexit, and then I'm specifying that on the java.lang.system class, I want to modify the implementation of the exit method. Okay, so I define a new function, and in fact, I do nothing. You see, I have just one line, but it's just for debugging purposes, just saying, okay, the system.exit function was called, but that's all. I'm not doing anything after that. So let's try it. Okay. Yes, so I have my Frida server running. Okay. And now yes, on the Apk workshops, if you look at Android/uncrackable level 1 So bypass route with exit. Okay, you can see it's the same. Okay, the same thing I showed you on the slide. So I can perform Frida-U -L. I can retry that. So this script -F to launch uncrackable level 1. And so I specify just the package name. Okay, let me see, normally I'm not mistaken. If I do that, okay, so you see it's launching, but it's okay, nothing has happened, it's blank because I didn't use the no pause option. So I need to specify here the %resume to continue the execution of the application. So we see our console.log here starting uncrackable 1. So I have the pop-up, which is normal. Now I'm going to click OK. I see system.exit function was called, and the function, the application, sorry, is not exiting. Okay. So the same thing we performed before by tampering the application, we did it right now just with 3 lines of, maybe more, 4 lines of Frida. Okay. Another way, just to show you, you can try it. I created another Frida script, but by modifying the ABC functions to return false each time. Okay. So this time you didn't have the pop-up, the application run without any issue. In fact, yes, we can run it just quickly to show you. Oh. If I do that. And you see no pop-up starting, and we have ABC. All 3 functions were called, which is normal, and that's all. Okay. To answer this. Okay. So that's it for bypassing the root detection. You see, it's pretty easy with Frida. So now we just need to retrieve the secret, and we are going to apply basically the same idea that we performed before. But in fact, we are going to, yes, maybe I'm going to show you. Yeah, in fact, we are going to hook this function. So if you remember here, so this function is used to decrypt the secret, which is this one. So we can hook this function to call it and to retrieve the result and to display the secret. And so the Frida script is just doing that. We use the sg.vantagepoint.a.a class, okay, and we implement the a method with the 2 arguments, arg1, arg2. We call the original function with the 2 parameters. We retrieve the value. If you remember, the value is a byte array. So we just need to translate it on a string to be able to display it. Okay. And so if you want to see that, we have also this script on, you have the solution, in fact, on the Github repo. Okay. Solution 1.js. Okay. And okay, so in this case, the bypass method, we just hook the ABC method. Now I can put everything I want here, click verify, and I obtain the secret decrypted with the Frida script. Okay. So you can see the solution using Frida with a rooted device. Okay, so now let's see how to do that using a non-rooted device. So let's imagine you have a device, you can root it, and you can only run it on a specific device, but you can't root it. So you can still use Frida against a non-rooted device. But as I said, you need to rebuild your targeted application with a libgadget. Okay, so the steps are pretty simple, but a little bit boring to do. Is you need to use Apk Tool to decode your application. You need to add the libgadget library inside the application. You need to modify the smally code to load the libgadget. And then you need to add the internet permission to the application, because Frida is going to listen on a specific port for the Frida client to be able to connect to the Android application. After these 3 key modifications, you can rebuild and sign the application and then profit. Sorry, I have a question here. Okay, so to perform this modification and to inject the libgadget, you have 2 ways to do that. The hard way, you can do it by hand, by modifying the application and perform the steps I showed you. Or you have the easy way, and the easy way is just to use the objection tool. Okay. So because we are running a little bit out of time, I'm not going to perform these steps, but I'm just going to show you. So you decompile with the Apk Tool. First, you modify the Android manifest, okay, and you add the permission, the internet permission, okay, as you can see here on the screenshot. Okay, pretty easy. It's not difficult to do. It's just boring. Then you need to retrieve the Frida gadget library. Okay, in our case, you have already this file on the virtual machine. Okay, and then on the uncrackable level 1, you need to create a directory, because in this case, for uncrackable level 1, we don't have any shared libraries used. But so you need to create the lib directory and a subdirectory with the correct architecture we are going to use. In this case, the emulator is x86-64. So we create this directory and we put the Frida gadget inside the x86_64 directory. Okay. So that's the second step. And the third step, okay, sorry about that. We need to modify the application to load our library, okay, our shared library, the Frida gadget, in fact. So the goal is to load the library very early when the application is launched. So normally the good option is to modify the main activity, the onCreate method, in fact, specifically, and to add our call to load the library. So usually it's a good point. It's a good place, sorry, to do that. So you can modify the main activity.smally file. Okay, sorry, we don't can see it very well now. And then you just need to add these 2 lines. Okay, the first one is just to put the Frida gadget string on the V0 register, and then we call a function system.load_library with our parameter. Okay, so we are just telling, please load the Frida gadget library you have inside the APK. Okay. So after that, you are ready to go. Okay, I have an example here. And you just need to recompile, to rebuild, sorry, the APK, sign it, uninstall the previous package, the previous application on the emulator, and install the new one. Okay. And then that's all. We can just reuse the same Frida scripts we used before. Okay. So you are going to have the same behavior as before. When you are going to launch the Android application, it seems to be stuck, and you have something blank like that, but it's normal. The Frida gadget is waiting for a connection from your side. So if you launch the application and do nothing, the application is going to start like that. Okay. So you can check if everything goes well on the logcat again. Look at grep on Frida, and if you have listening on and a specific port, it's okay. If you don't have that, if you have, for instance, I made a mistake before, and in fact I forget to disable the Frida server, and so the Frida gadget was not able to bind on this specific port. Okay, and then we can use the previous Frida script. Okay, so maybe we are just going to with objection to show you that it's pretty simple, and to show you that you can avoid the pain to modify the application. So with objection, it's pretty simple. You have an option called patch APK. You specify the APK. You can specify the Frida version you want to use. Okay, because if you don't specify it by default, objection try to download, sorry, the last Frida version available on the GitHub. Okay, and in our case we have the emulator running. Okay, so we don't need to specify the architecture. But if you want to modify an APK without any emulator or device connected to your computer, you need to specify the architecture targeted. Okay. So normally, if everything goes well, okay, it detected the targeted device architecture. So you see it's 8664. It uses the Frida version I say, and then you can see the different steps we already discussed before. He saw that the Android permission internet is not present on the Android manifest, so he's injecting the new permission. It is trying to define the class to inject the system load library. So in fact, he's going to modify the main activity, as you can see. And then he copies the Frida gadget to libspace. Okay. Rebuild the APK, build the new APK, sign it, and that's all. So if you perform a ls, you see a new file, uncrackable-level1.objection.apk. So this is the APK created by objection. Okay. So just to show you that it's working, I can install this one and install the objection one. Okay. Let's go back to the emulator. If I launch it, you see it's not what. Okay. Okay, demo gods are not with me. There is an issue here because normally Yes, I know. My fault. I forget to switch off the IDB server. So normally, okay. So now we are good. If we perform IDB logcat by prep Frida, okay, you see failed to start because I forget to disable the Frida server, and now we are good to go. So we can use Frida. But this time with another one, a solution gadget, okay, and OWASP. No, sorry, not at all. It's gadget because because we are using the lib gadget. We need to specify the gadget. We don't need to specify the oh, sorry, I can spawn it. Okay. And now the execution of the application continues. And we can see my Frida script works. And we have the same behavior as before. So sorry. So what I did wrong is we can spawn an application with gadget because we need to launch it by hand and then attach to it. So that's why. And you just need to specify gadget and not the package name of the targeted Android application. Okay. And of course, you can't have Frida server running in the same time. Okay. If you want, I can just show you quickly this, but in fact, it's the same. To bypass, we just hook the exit function, exit method, okay, to do nothing. And then we have still the same thing. We call the decryption method with the two arguments here. We retrieve the value, and yes, we convert the byte array in string and we display it. That's all. Okay. So that's all for the uncrackable level 1. If any questions, feel free. So as I said, we see 3 methods to do that: by tampering the Android application, using Frida on a rooted device, and using Frida on a non-rooted device using the lib gadget. Okay. Can the preference signature is not the original? Yes, but yes. So if the application performs some kind of integrity checks, it's possible. That app was not installed from the Play Store. For this one, I don't know. I don't see any way to do to check that. When running a modified application with Frida gadget, I need to launch it manually on Emulator and then I use Frida command. Yes, you're right. Yes, you can spawn it when you use a Frida gadget. You need to launch it by hand. Yeah. Yes, a specific log. It's because I added some console.log calls on my Frida scripts just for it's like using a print or a echo for debugging purposes. I can if I show you again. Yes, what you see is there's that console.log just to display starting uncrackable 1. Here the same, just to display the system action exit function was called, and that's all. This one is just to display the secret decrypted. Okay. Okay, let's keep going because time is running. Okay, so let's have a look at uncrackable level 2, if no more question on the level 1. So the ideas level 2 is pretty similar of level 1. Okay, we have a secret inside this application, and we have some clues about using native code. Okay, and in fact, we are going to see that sensitive part of the code is inside a shared library. Okay, so I hope you like reverse engineering some binaries, because we are going to do that now for this level. The only similar thing comparing to level 1, so I'm not going to lose too much time on this, is the root debug detection routine is exactly the same thing. Okay, we are going to see that on the Java code, but it's the same thing. The only tricky part, you can say, is the secret is hidden inside the shared library. Okay, in the previous example, only Java code, everything was in Java code. Okay, the secret was encrypted using AES, but we just need to manipulate, to hook, we can say, the Java code to do that. Okay, so from now we are just using Frida for convenience to resolve the other crackmes. Okay. So just a quick recap about native code. So when you create an Android application, yes, usually you write your application using Java or Kotlin. Now Kotlin it becomes the standard pushed by Google. Okay, but inside your Android application, you can embed some native code. Okay, usually it's written in C or C++, more usually in C++, in fact. And in fact, this native code is available as a shared library inside your Android application. Okay, you can find a lot of information about the native development kit on the native development kit. So, and so now the question maybe you are asking is, okay, I have Java code, I have a shared library written in C and C++. How can I interact with both? I mean, from Java or the other way? In fact, we have something called Java Native Interface, or JNI, okay, which is provides a way for you from your Java code to interact with a shared library and with your C or C++ methods, okay? But in fact, it's working also the other way around, okay? So from your native code, you can interact with Java or Kotlin methods, okay? So just to give you an example, on your Java code, for instance, if you want to use some native code, the first thing you need to do is to load the shared library. Okay, so you see the same technique used for the lib gadget. So somewhere on your Java code, you need to load the targeted shared library. Okay, and then you need also to define your native functions. Okay, so I mean, native functions is a function inside your shared library. So for instance, on your shared library, if you have a function called myNativeFunction or launch something, you need to define the prototype on the Java code. And for that, you can use a native keyword. Okay. So on the Java code, at some point, you are going to see some function with a native keyword, and you just are going to see the prototype. Okay, so that's for the Java code part. Usually, you are going to see this kind of behavior on your Android application. And for the native code, usually, when you define a function on your native code being able to be called from the Java code, you need to respect kind of specific naming. In this case, the methods on the native code to be able to be called from Java need to respect this naming convention. Okay, so it starts with Java usually, always. I mean, then the package name of your application, then the class where the method was defined on the Java code. Okay, so the native when you use the native keyword, and finally the string from the name of the method. Okay. So usually, if you look at the shared library and you can start, you find some methods starting with Java, you know that these methods are called from Java, from the Java code. And then by default, each native method called from Java have two parameters, two mandatory parameters, which is a GNI-env, sorry, which gives some how to say, not some parameters, but some yes, some functions, some calls to interact from Java. I'm going to explain later. And JObject, which is in fact the current object of the class from where the method was called. Okay. So a very, very, very simple example. In this case, we are just going to return a string from C++. Okay. And that's why we need the GNI-env is, okay, a string on C++, it's not similar to a string on Java. Okay. So to return this string, hello, we need to call a function which is available on the GNI-env object to convert our string or C++ string, we can say, to Java string. Okay, so using this this function. Okay, I'm not going to bother you too much with that, but just to be aware about that. Okay, so that's it for native code. Okay, you just need to know that at the moment to resolve the crackmes. Okay, so let's have a look at the uncrackable level 2. Okay, again with JADX. As usual, we look at the Android manifest. Okay. Again, a small Android manifest. We just have only one activity. Okay, which is the main one. Okay, and nothing more interesting on the manifest. Okay, we have the package name. Okay, which is similar. Sorry, which is similar to the previous one. Okay, so let's go to the main activity. Control plus click left. Okay, so we know that we are dealing with some shared libraries because you see there a load library for the full library one. Okay, this A function, if you remember the level 1, the same, just to display the pop-up and to exit when you click OK. Okay, and then we have some functions to detect root and app, which is the same. Here we have an init function, and you see that we see the native keyword. Okay, so this one we don't have the implementation here, but on the shared library. Okay, and let's have a look. Yes, we have a verify function. And verify function, okay, works pretty similar to the previous one. We retrieve the user input here, and then we call this function, this.m.a, okay, with our user input. If this returns true, that's good. If not, we didn't find the secret. And so this M, so M is from the code check class. So let's have a look at the source code. We are on uncrackable. We are here, uncrackable 2, and yes, we have a class called codecheck. Okay, and on codecheck, if we have a function which takes a string and called the bar function, and our string is converted in bytes. Okay, and bar function we can see is a native function. Okay, so in fact on the Java code we have pretty nothing. We know that we found that we have a shared library loaded. We have one init function on the native code called on the onCreate. Okay, so we need to bypass that, but we know how to do that. And for the verify, we call the this.m.a function, which in fact calls the bar native method on the shared library. So in fact, we need to reverse engineer the full library. So in fact, already on the JADX software tool, we can see the lib directory, okay, and on it you can see 4 subfolders, okay, for each architecture, okay. In this case, it's nice. The application is compiled for this 4 architecture, okay, x86, ARM, and so on. But sometimes on real life, you don't have all these subfolders. Sometimes developers are only going to compile for ARM architecture, okay, because normally your physical device only use ARM and are not using x86. And if we look at the subfolder, I mean, if each one, we are going to see the same thing, a libfoo.so file, okay, which is a shared library. So to go further, we need to investigate this library to find the secret. Okay, so let me see. Yeah, I thought about that. Okay, yes. So we are good. So to do that, we need to retrieve the shared library. So let's use Apk Tool. Okay, just quickly to have access to the shared library. At the same time, in fact, we can launch Ghidra. We are going to use Ghidra on this case. Okay. Yes. So you can use find to see the. Okay. I don't know if you are really familiar with. Come on. Here. Okay. So let's start a new project. Non-share project. We don't care. Project name. Let's call it libfoo. Finish. And we are going to import so the shared library. So on Android, OWASP crackmes, uncrackable level 2, which is output of the Apk Tool, lib. Let's take x86 libfoo.so, select file to import. Yeah, that's good. Okay, perfect. And normally, yeah, Ghidra is Java, so if what's not been analyzed, would you like to analyze it now? Yes. So analyze, do it. And in fact, so if you remember, we already find 2 interesting functions on the Java code, init and bar. Okay. And so on the function, it will be pretty easy to find them because we have the native keyword used. So from the naming convention, it should start with Java. And in that case, we have the 2 functions here. Let me. And so you can see the same naming convention I presented to you: Java, the package name here, and the class name. Okay. Let's see if there is a question. Yes. So yes, good remark. Okay, I didn't want to introduce that on this workshop, but you're right. In fact, you can register the native functions dynamically. And so when you do that on the native, on the shared library, it's not going to appear on the Java code. You don't need to define them, the prototypes on the Java code. So you need to, in fact, you can find them if you look at the shared library and you look at the call of the register natives on the shared library. So of course, it's more boring to do that. But okay, anyway, for us, in this case, on the crackme, we don't have a dynamic native functions defined. hopefully. Okay, so init. Let's have a look at the init function. So which is good. I mean, which is great with Github because I'm not very good at reverse engineering binaries. Is you have the decompile window, which can give you some insight on what's going on the binary. Okay, so on the init function, you can see we have a call on the anonymous function. So we can go there and see what's going on. Yes, there is some, yes, on the init function, but yeah, I didn't talk about that. On the init function, there is some kind of detection to see if you are not debugging the application. But in our case, we are performing Frida hooking, so we don't care about that. But if you analyze the init function, you can find that, okay? But nothing more interesting for us on this init function. So we can have a look at the bar function, and now, in fact, okay, if you have used to analyze binaries, you can see some local variables release range. Okay, here. In fact, it's secret splitted in various parts. Okay. So if you remember, which is important is when you are looking at this method. So if you remember the first parameters, usually you don't care because it's part of the Java environment. So normally it's nothing important for us. Param3, so if you remember for the this.ma, if I go back to JADX, so the bar function take a byte array. Okay, in this byte array is a user input. So let's follow this parameter to see what happens. So it's param3. Param3, you see, is we retrieve, yes, there is kind of cast, I guess, because it's a byte array, Java byte array. Okay, and so it's casted on a card pointer. Okay, and it's stored on the is1 variable. Okay. The second line, in fact, it's just to retrieve the length of the user input. Okay, and you can confirm that because after that we have a if comparing the evar1 variable with a decimal. I mean an hexadecimal here, which is 23 in decimal. And then we have a strn. Oh, no, I don't want to do that. Sorry. Okay. No. Okay, what I did. Okay, so as you can see, I'm not very used to use Github, and I lost this window. Okay. Yes. Okay. Good. Okay, let's go back. So yes, we look at the length of the user input. Yes. Okay, I made something. Okay, and normally here this function, maybe I rename it, but it is str compare with our variable and the secret. Okay, so let me switch to the slides to show you. Yeah. So you can see what I showed you before I made a mistake with Ghidra. So we compare the length of the user input and then we perform a str and compare with the user input and this variable, which contains, in fact, the secret. And you can see, in fact, the secret is split in different parts. And the comparison is made with the same length defined here. And if it's okay, we find the secret. And if not, we need to try harder. So from there, it's practically done. What we just need is to find a way to retrieve this value here. Okay. On the parameter of the str compare. So in fact, we can use Frida. I show you how to use Frida from hooking Java code, but in fact, we can use Frida to hook native code also. Okay, so the idea here is pretty simple. We are going to hook the str and cmp function to display the arguments provided. Okay, and at some point we are going to find the secret. Okay, so to hook native code inside the Android application, we can call the interceptor API from Frida. Okay, I'm going to show you just a small example. We are going to use this one. So the easy way to use interceptor is using the method attach. And the method attach, it allows you, in fact, put callbacks on the when you enter the function and when you leave the function. Okay. So in this example, it's pretty simple. I'm going to attach to the read method from the libc library. Okay. So instead of giving the good memory address, we can use a module.find export by name. Okay. So if the name is exported on the application, on the library, you can use that. And so we are going to say, okay, I want to attach to the read method with interceptor.attach. And then we define two callbacks, on enter and on leave. If you want just one of them, you can just define one. You are not obliged to define the two callbacks. But in this case, okay, in fact, I define both, but I'm just using on enter, and I'm just saying here, okay, when I enter the read function, I'm going to display the parameter provided to read. Okay. Pretty simple. So we are going to use that to retrieve the secret on the strncmp method. Okay. So as you can imagine, strncmp is probably used a lot in the context of the application. So we don't want to display each call. So what we can do is perform a check and saying, okay, if the parameter, for instance, we are looking for the user input. Sorry, if the user input starts with a boundary sec, so we display the other argument, because we know that if the argument, the user input starts with a boundary sec, it's something what we put. The only thing is to respect the length of the expected user input. So in decimal is 23, okay, on hexadecimal it was 17. And here it's pretty easy to hook the strncmp function. We can just make a call on module find export by name, specifying libc, because strncmp method is from the libc library, and specifying the method. Okay, so normally, yeah. So here you have the solution for the level 2. So we are going to see. Let's start with the Java part, which is easy because it's already the same thing we saw before. We are just bypassing the exit call, okay, by doing nothing. Okay, and now with the interceptor.attach, we are going to attach to the strncmp, okay. And we just need to use a callback on enter. So if you remember the strncmp, let me go back to strncmp. Okay, you see there you have 3 parameters. The first one in our case is the user input. The second one is the secret, and the third one is the length. Okay, so we don't care about the length, but we care about the first parameter and the second one. So pretty easily, in fact, we take the first argument. Okay. So yes, on native code, everything is an array. So for the parameters, you just specify one variable and then you use it like an array, in fact. And then on the same way from Java, because arg0 and arg1 are pointers, car pointers in our case, we need to convert them to be able to read them on the JavaScript side, okay? Because if we don't convert them, we have just pointers, and so Frida is going just to display the address and not the content. So to retrieve the content, we need just to use this function memory.read utf8 string. Okay. So param1 is the user input, if you remember. Param2 is a secret normally. And to be sure that we are targeting the specific call we want, we perform a check on param1 and look at if it starts with run reset. If this is the case, we can just display param2, which is a secret. Okay, so this is our Frida script to resolve the challenge. So, okay, can forget about that. I can show you. Where is my emulator? So this one we don't care. Come on. I didn't install Uncrackable level 2. Let me do it. Okay, perfect. We can check if I launch it. Okay, same behavior as Uncrackable level 1. Root detected. I click OK, and the application exits. Okay. So on the Github repository on Android, Uncrackable level 2 folder, you have just one Frida script solution UL2, and you are going to find the same thing I showed you on the slides. Okay, so this part is just to bypass the root detection, and here we are going to attach to the str and cmp method, and then display the param2 if param1 starts with run reset. Okay, so I guess I switch. It was yeah. Okay, I have something running again. Let me kill everything. So I guess now it's going to work. Yes. Let me check. Perfect. Okay. So now I can use Frida. But I want level 2 solution. I showed you -f, and it was owasp.mstg.unbreakable2. Okay. No pause to avoid to type resume. Okay, starting. To detected is normal. Now I click OK, and that's good. So now for the secret, so 23, I need to start with run reset. Let's do it. Run reset is 10, so I need 13. 1, 2, 3, 4, 5, 6. Okay, so now let's click verify. Normally now I have the correct length for the user input, the user input starts with Android sec. So when the strncmp will be called, it's going to display the secret. Okay, so it's not the secret, we know, and we can see here, secret is thanks for all the fish. Okay, so we can confirm that. We need to put the paste. Normally, it should work. And that this is a correct secret code. And now we nothing is displayed because the user input doesn't start with Android sec. Okay, which is normal. Okay, so okay. So I guess we are not going to have time to do uncrackable level 3. I can just present to you. So of course, level 3 is harder than level 2 and 1. On level 3, sorry, you are going to find the same technique for the root and debug detection. Okay, it's basically the same as level 1 and 2. And same as level 2, the secret is hidden inside the shared library. But in addition, what you have on the level 3 is you have some anti-hooking and anti-tampering protection were implemented. Okay, so depending on how you want to resolve the crackme, you need to bypass them. If you look at the slide, you see that the anti-tampering protection, we don't care because we are not going to modify the Android application on the solution presented, but we need to bypass the anti-hooking. So anti-hooking, you are going to see the level 3 is performing some system calls to check if Frida or exposed tools are running on the device. Okay, and if it's the case, the application is going to exit also. But the anti-hooking mechanism is performed inside the shared library. Okay, so which is funny. We are going to use Frida to bypass the anti-hooking protection inside the shared library. Okay. Okay, so you have everything on the slides to perform the level 3. I hope very well explained. I'm going to update the slides because I see we have some issues with some tables. So maybe we have 5 minutes, I guess. If you have some question, feel free. We can use this time for that. Okay. If no question, we can stop the session now.
I see a question.
Ah, yeah. Yes. So on the slides, you can see at the end some references if you want to go further. Let me show you. Yes, so of course, yes, the one I recommend is a mobile security testing guide from OWASP. It's I mean, it's a cool guide, very detailed, and of course on it you are going to find some other interesting resources. You have a blog post from Evil Socket, which is more beginner friendly, we can say, which is a good resources. At RunRuSec, we created some mobile hacking cheat sheet for Android and iOS. We can have a look, but yeah, as the name implies, is more cheat sheet. Frida, some references here. Yes, if you want, you can also look at the solution provided by Innovel. But yes, short answer, MSTG. You can read it. It's really good resource. Other questions?
I think that we are done. Guillaume, thank you very much.
Thank you. Sorry about the virtual machine. Yes, we know that Google sometimes block and limit the downloads, but I'm going to keep the link available for people who want to download this virtual machine. I mean, in the few days, it will be still open. What else? Yes, virtual machine. The slides, I'm going to update it. And yes, sorry to not have time to perform the level 3. But yes, as I said, honestly, the slides are pretty well detailed if you want to do it. Okay, so thank you all, and enjoy the OWASP AppSec Israel event.
Thank you. Have a good day, everyone. Enjoy the other sessions. Guillaume, thank you again.
Thank you. Have a nice day.
Bye-bye. Bye-bye.
Bye.